We're standing right at the edge of one of the biggest shifts in AI. We're about to move from tools that we command to autonomous assistants that actually act on our behalf. So, what's the secret ingredient? What's the hidden piece of tech that makes that huge leap possible? Well, let's break it down. Think about the AI you use every day. You ask it a question and gives you an answer. You give it a command, it does the thing. It's powerful for sure, but it's always, well, it's reactive. It just sits there and waits for you. But what if it didn't have to? And this is the vision for the AI agent. It's not some tool you have to pull out of a digital toolbox. Nope. It's a proactive partner that's always on, always working for you in the background. Kind of like having a personal chief of staff for your entire life. Okay, so to really wrap our heads around this shift, we've got to get super clear on the fundamental difference between the GPTs we're all using today and these new emerging AI agents. So here's the absolute core of it. A GPT is a reactive tool. The best analogy is a calculator. It's incredibly powerful, right? But it doesn't do a single thing until you pick it up and punch in a problem. An AI agent? It's the complete opposite. It's a proactive assistant, always on, that can actually start tasks for you because it understands what you're trying to achieve. So how does an AI even make that jump from just responding to actively doing things in the real world? Well, for an AI to become a true agent, it basically needs two components that mirror us. It needs a brain, and it needs a body. First up, the brain. This is the large language model, the LLM. You're already familiar with this. It's the smarts behind things like ChatGPT. It's the part that can think, that can reason, and, most importantly, make decisions. And then you have the body. And the body is built from things called APIs. Think of APIs as the agent's senses and its hands. They're what let the LLM brain connect to the real world, to read your calendar, check your GPS location, or actually perform actions like booking a dinner reservation or turning on your smart lights. So we have a brain, we have a body. Simple enough, right? Well, not so fast. The real challenge, the bottleneck that's held this all back, has always been the connection between them. How do you get all these different parts to talk to each other reliably without everything falling apart? See, in traditional software, when two services need to talk, it works kind of like a direct phone call. One service literally calls up the other one and has to wait on the line for an answer. This is called a tightly coupled system, and let me tell you, it is incredibly fragile. Just imagine you place an order online. The order service needs to call the distribution service to say, hey, ship this item. But what happens if the distribution service is down for maintenance for just a second when that call is made? The line's busy, the call fails, and your order, well, it could get lost in limbo forever. The whole process just breaks. Now, obviously, for an AI agent that's supposed to be working for you 24/7, that kind of fragility is a total non-starter. It just won't work. We need a much, much more resilient and fault-tolerant way for its brain and all its body parts to communicate. So instead of that fragile phone call, what if communication worked more like a text message? You don't wait on the line, right? You just send the message and you trust that it'll be picked up whenever the other person is available. This is what we call asynchronous or loosely coupled communication.
Okay, let's go back to our online order with this new model. This time, the order service doesn't call distribution directly. It just drops a message that says, ship this item into a shared, super reliable inbox. So now, even if the distribution service is offline, that message just waits there safely. And when the service comes back online, it checks the inbox, sees the message, and ships your item. Success. Nothing ever gets lost.
So what is this magical, reliable inbox that makes this whole thing possible? Well, the technology behind it is called event streaming, and it is the architectural key that unlocks these truly autonomous agents. Honestly, the best way to think about event streaming is to see it as the application's central nervous system. Every single action, an order being placed, your location changing, a smart light turning on, that's an event. The nervous system senses that event and instantly, reliably transmits the signal to any part of the body that needs to react to it. And the most popular technology for building this nervous system is something called Apache Kafka. Its model is just beautiful in its simplicity. You have a producer, that's like our order service, that sends an event message. That message gets published to a topic, which you can think of as a dedicated broadcast channel just for, say, new_orders. Then any number of consumers, like our distribution service, can tune into that channel to get the messages and act on them in real time. And this is why this is a total game changer for AI agents. This architecture gives them exactly what they need to survive in the real world. Services are loosely coupled, which means there are no single points of failure. The whole system is resilient, so one part can go down without crashing the entire agent. And on top of that, it's incredibly fast and scalable, allowing an agent to process and react to millions of real-world events instantly. So this event-driven architecture, it really is the robust foundation for this whole next generation of AI. But it also raises a really profound question, doesn't it? As these autonomous agents become the nervous system for our actual lives, how do we make sure that system is not just powerful and resilient, but also fundamentally trustworthy? That, right there, is the challenge ahead of us.